This is Minor Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate. Please don't share personal information like contact or social media info during class for your own security reasons. All right, let's go ahead and go over our brain stretch here. So does mass change based on where you are in the universe? No. Remember, mass is the amount of stuff you're made up of. Stuff you're made of. And does the amount of stuff you're made of change based on where you are in the universe? Yes or no? Does the amount of stuff you're made up of change? Okay, yeah, no worries, Aqua. You can always turn things in late for full credit. We obviously just want to get things as closely done as by the due date as possible. Otherwise, it builds up really quite a bit. Yes, no, the stuff you're made of does not change. Therefore, your mass does not change. Your weight, though, does change based on where you are in the universe because weight is dependent on both mass and what? What is that force that changes how much you weigh? Tell me in the chat box. Yes, Shelby. Yes, Landon. Gravity. Gravity changes, right? So based on gravity, lots of gravity on Earth, you're heavier. Little gravity on the moon, you're lighter. No gravity in outer space, you are weightless. All right. A 1,000 kilogram, 10 kilogram object. Obviously, it doesn't matter how much they actually weigh or their mass, because if they're only experiencing gravity, they actually hit at the same exact time. So the speed at which you accelerate, the amount in which you accelerate towards the ground, if it's only dependent on gravity, then they hit at the same exact time. It's not dependent on mass, not dependent on weight. Doesn't matter how heavy you are, how light you are, you will hit the ground at the same time. Yes. Earth and the moon have equal gravitational forces. Now, remember, the large mass like the Earth actually ends up with a small acceleration. Remember that mass and acceleration are actually they are inversely related. Okay, so a big mass like the Earth actually has a small acceleration. This is why the Earth does not spin around the moon. Smiley faces if that makes sense. This is why the Earth actually does not spin around the moon, because it has a much smaller acceleration. It just kind of wobbles. Just wobbles. All right? Now a small mass, then tell me in the chat box, what should this one be? A small mass should have what kind of acceleration if they're inversely related? A small mass like the moon should have what kind of acceleration? Tell me in the chat. Yes, exactly. It should have a large acceleration. And that is why the moon actually does make a really big circle around the Earth, right? So the Earth does not make a big circle around the moon. The Earth just wobbles, whereas the moon has a large acceleration, so it actually orbits in a large circle around the Earth. All right, give me one more time, thumbs up if that makes sense. Remember, this was called the barycenter. We talked about this in one of our previous classes. The barycenter is the result of the mass of the Earth being so big that it actually is rotating around each other, but for the Earth, it just kind of wobbles, all right, because the Earth is just so massive, acceleration is much smaller. Now, vectors show both magnitude and direction. That's true. Magnitude meaning the amount of force or velocity, direction meaning the way in which that force or velocity is moving. If objects are unbalanced, that means you do have a net force. Okay, so you do have a net force, and anytime you have a force, you have an acceleration. And tell me in the chat box, guys, which way do you think this object will accelerate? Will it accelerate in the same direction as the net force, as the overall force, or the opposite direction as the overall force? Think about if you're pushing something overall to the right, which way does that object move? The same direction to the right, or the opposite to the left? If you push something to the right, it moves to the left. If you're pushing something to the right, your net force is to the right, then which way should the object move? Is it going to go to the right as well, or is it going to go opposite to the left? Same direction or opposite direction? All right, so here's my object. Here's my overall net force. Which way does the object move? Yeah, it moves in the same direction, yeah. So in this case, it actually moves in the same direction. I know, Nichelle, you're like, but equal and opposite? I'm so confused. There's too many concepts. No, I wasn't trying to trick you, okay? If you have a net force, it moves in the same direction as the net force. Whichever way you push it, that's the way it goes. All right? And then lastly, if forces are balanced, they cancel out, then the object's just going to stay at rest because no force means no acceleration. Go ahead, give me a round of applause if all of this makes sense to you. Go ahead, give yourself a round of applause if you feel good about all these different questions. Awesome, Lorelai. Awesome, Micaiah, Nichelle. Thank you, Hannah. Thank you, Antonio. Looking good. All right, everyone. So we are in our attendance check. Make sure you already have that open. Start of class word is underneath the link in the chat box. Make sure you fill that out. I only give it out for the first 15 minutes. So if you're not getting it now, you're going to miss it. So make sure you get it right now. Okay. Now, here is my contact information. Remember, if you ever run into any issues, have questions, definitely contact me. You can text me or call me 424-294-8688, or you can email me bfiorellolarkin@k12insightca.org. I think there's also a direct email link on your course page. Emailing is usually the best bet unless it's like an absolute emergency, because emailing is easier for me to respond to based on like not interrupting my other meetings and classes. Remember, you do get 3 attempts on every assignment. So if you don't do well the first time, especially today is a lab, it's a huge part of your grade because labs and exams are always huge parts of your grades. So if you don't do well the first time, try again. Okay. So today we are completing the net force lab. We are going to do our lab. Again, we do have attendance because we do have a required class. We have classes Tuesday through Thursday for the rest of the week as well. Remember, even though on Friday you don't have class, do you still have an assignment? Yes or no? Tell me in the chat box. Even on Friday, though there's no class, do you still have an assignment? Yes, you always have assignments, all right? There will just be a recording. How about yes, Aqua? There will be a recording to go over the 5A notes. You will notice that we do have our next exam on Thursday. I'm sorry, Unit 4 is actually a pretty short unit, which is why we end up with an exam and a lab in the same week. It doesn't happen very often, but this time it did. So that kind of sucks, but we're going to get through it anyways. Okay. So again, you do have class every day, Monday through Thursday this week. You will notice that there is no optional support on Wednesday. I will not be in the office on Wednesday in the afternoon. So we don't have support on that day, but we would still have optional support on Friday morning at 8:30. Okay, so and everyone's been invited to that, but again, it is optional if you just need extra help or if you want to check in with me. The quarters are 45 days long, so you can see the countdown here. So we are on day 15 out of 45. 15 out of 45 is also 1/3, so we're officially a third of the way through the quarter. So it's going by quickly, right? All right, so we've been talking all about forces, friction, gravity, vectors. So this lab is actually going to be quite a bit about vectors. No. We've only done 15 days. We still have 30 days left, 30 school days left. Don't worry, Aqua. You're like, wow, we still have like 7 units to get through. How's that going to happen? All right, so today we're going to take a look at our lab, which means that we should be able to determine the magnitude and direction of net force on an object using vectors. This is actually something that you already reviewed on Friday's video, but we're going to review again today, just in case you didn't watch Friday's video yet. And then we're also going to demonstrate how different forces acting on an object influence its motion. So we're going to talk about vectors, net force, how to calculate it, the purpose of our lab, and then I will be giving you a video with all of the instructions. I do know that Adobe Flash was not working for a lot of students, so instead I just recorded the entire lab for you. So all you need to do is get the data from the lab. Smiley faces, everyone, if that makes sense. So you don't have to actually do the lab on your own. Everything's already in the video for you to make your lives easier. Okay, you still have to get your own data, but it's already in the video. Okay? All right, so if we're in the live class, we should be able to open up our lab report right now. If you have issues opening up 2 things at one time, you can take pictures. You can also close your attendance ticket as long as number 1 is saved. So you have lots of options. Give me a green check, though, when you either have the lab open or you're ready to take pictures. Either one's fine with me, but you need to be ready for one of those. So you have the lab open or you're ready to take pictures. I'm going to give you 30 seconds. Go. All right, green checks, please. Alejandra, Alicia, Lexi, Alicia, Brandon, Chris P. David, thank you, Aqua. Estella, waiting on you. Jorge, Landon, Taviana, Travis, green checks. Okay, yeah, just finish up your last question, turn it in, and then I will grade it. Again, if you see a 0 ever in your gradebook, guys, you can still redo everything. The only thing you can't redo is attendance, because obviously that's a live thing. But everything else you can redo at any time. So even if you got a 0 the first time around, make sure you do it. You get 3 attempts, okay? And you'll still get full credit as long as you turn it in correctly, okay? All right, so if you're ever watching the recording, the lab is underneath the Content tab. Go to Content, click the Unit 3, scroll down, find the 3D lab, and then click Start Quiz. The instructions for the lab are being provided step by step throughout this lesson. Again, you do not need to do anything for the lab on your own. You just need to watch the video. I'm giving you the every step for the lab, okay? We're going to start it in class, just like last time. I'll give you the video and you'll start it in class, okay? All right, so let's review vectors really quickly. So forces are vectors because they have both a magnitude and a direction. Remember, the magnitude meaning how long the arrow is or the amount of force. So think about this. A long arrow, does that show more force or less force? Tell me in the chat box, does that show more force or less force? That should show more force, exactly. So longer arrows show more force, smaller arrows show less force. Awesome. David, let me check yours. You're logged in already and everything? No, I don't know why that's not working for you. David, let me go ahead and send the link to you again. Otherwise, go to Content, Unit 3, and then open it up from the Content tab. Okay, does that make sense? You can open it from either direction. You click the link and it doesn't load. Okay, so David, yeah, go to Content tab. All right, click Unit 3 from the left menu, and then scroll down and click 3D Lab. Okay? Let me know if that works. All right, and then the direction obviously is where it's pushing or pulling towards. So whichever way it points, that's the direction of the force, right? So for example, the force due to gravity is pulling in which direction? Tell me in the chat box. Take a look at our vector here. The force due to gravity, which direction is the force due to gravity going? Yes, it's going down because the arrow is pointing down, obviously. Good. Now, here's the deal. We talked about this during our brain stretch. If forces are unbalanced on an object that starts at rest, then you do have a net force, and so the object will actually move in the same direction as that net force. It will begin to move. It will begin to accelerate. So, for example, take a look over here. You can see that if we have two forces moving to the right, a 5 Newton force and a 10 Newton force, let's imagine there's a big person and a small person pulling on this object, then overall they add up to a net force of 15, and that means there is a net force, and therefore the object begins moving in the same direction. In this case, which way will the object move? If objects move in the same direction as their net force when they start at rest, which way will this object move? Yes, it's going to begin moving to the right, so it will move to the right. All right, same thing with down here. Even though the forces are going in different directions, the 10 Newton force still ends up being stronger. So 5 newtons to the left gets canceled out by 5 newtons to the right, but there's still an extra 5 newtons to the right. So you can see overall we do end up with a total net force to the right, and so this object will still move to the right. Smiley faces if that makes sense. It'll just move a little bit. It'll accelerate a little bit slower just because there's someone working against it. Now, if forces are balanced, meaning they're completely canceling out, like you can see here, 5 newtons to the left, 5 newtons to the right, completely cancels out. Okay, so attendance, all right, so your entire OLS. Okay, so David, go to your settings. Go to your history, actually. History, and then I want you to go to, where is it? History. So history is Control H if you're in Google Chrome. And then on the left, I want you to click Clear Browsing Data. And you're not going to clear everything. Instead, all you're going to clear is your cached items. So uncheck everything and only check cached images and files. And make sure the time range is from all time. And then clear that data. Okay, you can actually still do it in Firefox. All right, so it's still probably a cache issue. So maybe really quickly Google how to clear cache in Firefox. And then clear your cache, okay? But only your cache. Don't erase everything, because that's always sad if you erase everything. All right, so let's go ahead and actually try this out, everyone. So take a look up here. We've got 2 newtons to the left, 8 newtons to the right. Now, here's the deal, guys. Remember, forces do have directions, and we can represent those directions with positives and negatives to make our lives easier. So 2 newtons to the left, what is that? Is that a positive direction or a negative direction? Take a look at my red axis here. When it's pointing to the left, is that positive or negative? Positive or negative? Awesome. Yes, this is actually a negative 2 newtons. To the right is actually positive. So add those together. What does negative 2 and positive 8 make? Tell me in the chat box. Negative 2 and positive 8, what does that make? Yes, it actually makes positive 6. All right, so it's actually a positive number just because the positive number is bigger. So negative 2, positive 8 should actually make a positive 6. So overall, my force is going which direction? Overall, my force is going which direction? Tell me in the chat box. Yes, to the right. Anytime we have a positive, it's going to go to the right. So this is a positive 6 newtons to the right. All right, and tell me which way will this object begin to also move? If my net force is to the right, which way will it also move? Yes, also moves to the right, accelerates to the right. Excellent. Now let's go ahead and try this one. So we've got 10 newtons to the right, 2 newtons to the right. Both of those numbers should be what? Positive or negative? If they're both moving to the right, they should both be what? Yes, they should both be positive. So positive 10 and positive 2 make what? Combine those together, add them up. Yes, you should end up with a positive 12. So a big positive 12 to the right. Again, I'm drawing it with a big arrow to show that it's a much bigger force. And again, my net force tells me that which direction will this object move. Net force, the object will move which way? Moves to the right as well. Excellent. All right, let's try this one out. So we've got 8 newtons to the left, 8 newtons to the right. So the 8 newtons to the left is what? Positive or negative? Yes, negative 8 newtons, positive to the right. And what does that equal, everyone? Tell me in the chat box. Negative 8, positive 8 gives me what? It gives me 0. So in this case, I'm just going to type here that net force equals 0. Net force equals 0 newtons. And if it's 0 newtons, what happens to its motion? If it starts at rest and there's no net force, what happens to its motion? It stays where? Stays at rest. Stays at rest. Excellent. And last but not least, and this one is actually in your lab. It's question number 1 in your lab. If we have 10 newtons to the left, is that positive or negative? Negative. 5 newtons to the right and 3 newtons to the right should be what? These ones, should they be positive or negative? Yep, positive, positive. So what we're going to actually do to make our lives easy is we're actually going to combine the ones on the right first. So positive 5 and positive 3 equals what? Positive 5 and positive 3 equals what? Yes, it actually equals positive 8 newtons. So now think about if we've got overall negative 10 to the left, overall positive 8 to the right. What does negative 10 and positive 8 make? Yes, it should actually give us a negative answer, and that negative answer should actually be negative 2. So which direction does this go? So Vanessa, just make sure negative 10, positive 8, some of that cancels out to make negative 2. Yes, no worries. Yes, this is actually going to go to the left. So your answer here is negative 2 newtons. Negative 2 newtons. And in this case, it means it's moving which direction? So net force means that in this case, which way is it moving? Moves to the left. All right, so your answer for number 1 in your lab, is right here. The answer is negative 2 to the left. Goes left, going left. All right, go ahead, answer number 1 in your lab. Give me a green check when you have it saved or you've taken a picture. You have 30 seconds. Go. All right, green checks, please. Asia, Alejandra, Alicia, Chris P, David, Estella, Jackie, Jarrett. David, I know you're still having issues maybe, but just take pictures if you can and then give me green checks just so that you have it for when class is over. Waiting on Jordan, waiting on Sean. Green checks, everyone. Looking good. Thank you, everyone. All right, let's keep moving. All right, so now we're going to go ahead and take a look at what happens when we have more than just left and right. All right, so what happens when we've got up and down? What happens when we've got one going up to the right? All right, so let's think about this. So take a look here. When we have up and down, we still have the same thing where up is positive and down is negative. So this upwards 45 newtons, what should I label that as? Positive or negative? Upwards 45, what is that? Positive or negative? Yeah, this one's going to be positive. And what about the downwards 45? The downwards 45 is what? Positive or negative? Negative. So we actually always do up and down together and then left and right together. So let's think about this. Positive 45 and negative 45 should equal what in terms of vertical motion? Yes, this actually equals 0 newtons overall. So vertical motion, so net force vertically equals 0 newtons. Okay, so the object is not going to accelerate up and down, right? That should make sense. Now, what about left and right? So again, we have a 45 newton force going to the left. What is that? Positive or negative? Yes, this one is going to be negative. And 15 newtons going to the right, what's that one? Positive or negative? 15 newtons to the right, is that positive or negative? Yep, this one's positive because it's going to the right. And now we're going to go ahead and do the horizontals together. So negative 45 and positive 15 should give me what? Negative 45 and positive 15 gives me what? Not exactly 35, close. So yes, 30, but in the negative direction. Yes, Asian. Yes, Nichelle. Smiley faces if that makes sense, everyone. Negative 45 and positive 15 actually gives us negative 30. You can always plug it into a calculator if you need to. Just make sure you keep your positives and negatives correct. All right, so overall, our net force horizontally equals negative 30 newtons. Negative 30 newtons. And in that case, which way does this object move? It doesn't move up and down, but in this case, it actually moves which way? No up and down, because up and down was 0. But which way will this object end up moving? Yes, it's going to move to the left. Moves left. Awesome. So this is actually the answer to number 2 in your lab. Oops, sorry, one second. This is the answer to number 2 in your lab. Let me highlight this one for you. Go ahead, give me a green check when you have number 2 in your lab saved. You have 30 seconds, go. You can also take a picture. All right, looking good. All right, let's go ahead and try this one. So here we've got 150 newtons going up and 250 newtons going to the right. Now, do up and right cancel each other out? Can we actually cancel anything out here? Can up and right cancel each other out? Vertical motion and horizontal, do they cancel? No, right? So these ones actually don't cancel it out. Instead, they're going to combine to create a motion in which direction? Tell me in the chat box, which direction do you think these will combine to make? Not directly to the right, because there's still upward force. So it's not going to go directly to the right. Tell me in the chat box, what do you think? If it doesn't go directly to the right, it's going diagonally which way? Diagonally? Yep, up and to the right, or you could say north and to the east, right? So overall, our net force here is actually going to be up and to the right. But in this case, do you think it's going to be closer to 150 newtons or closer to 250 newtons? Think about which one's stronger. Still kind of like a tug of war. Yeah, it's going to be closer to 250. So it's still going to be diagonal, but I'm going to draw it a little bit closer to 250. Smiley faces if that makes sense. So our net force here is up and to the right, but slightly closer to the stronger one. Good. All right. I'm not going to have you calculate magnitude for that one. That requires a little bit more math than we're used to right now. But last but not least, let's go ahead and take a look at this one over here. Is there anything that cancels out over here on the right for the green box? Is there anything that cancels out? Or that we can actually subtract? Yeah, up and down, right? So we've got positive 10 newtons up and negative 15 newtons down. So what does the vertical motion end up being? What does overall the vertical motion end up being? Okay, yeah, David, just take pictures and then we can go ahead and try it after class. I wouldn't worry about it right now just because that might be distracting. Yeah, oh, okay, Aqua, go do that. All right, so overall this should end up being negative 5 newtons going south, negative 5 newtons going south. Awesome. So that's what overall this equals. Okay, so overall the vertical motion is this. But think about this, we still have 20 newtons going east. So in that case, which way does the overall motion end up being? Again, we still have going down and east. So they're not going, going south and east. So they're not going to cancel each other out. What's going to happen? How do they combine? Yep, they're going to go southeast, but closer to which direction? Think about which one's stronger. Is it going to go more south or more east? 5 newtons south or 20 newtons east? Yeah, it's going to go more east. So I'm going to again draw this net force going more towards the east, but still diagonal between the two. Go ahead, give me a smiley face, everyone, if you feel comfortable with this now. Now that we've done this several times, practiced it, love it. All right, cool. So go ahead on the board for me. Match these up. This is going to be number 3 in your lab. Vector, unbalanced forces, balanced forces, has a net force, so object begins to move. Arrow showing magnitude and direction. Net force equals 0, so the object stays at rest. Oh, no worries, Vanessa. Oh, that's why you said south. Gotcha. Makes sense. I'll go back to it in a moment, David. Okay, think about unbalanced. Does unbalanced mean they cancel out or don't cancel out? Think about unbalanced. Unbalanced. There we go. We got to correct these. We got vector for sure. Vector looks good. But we got to correct unbalanced versus balanced. Good. All right, let me go ahead and pause the tools here. I'm going to grab my lines here and shrink these down. All right, so I'm going to grab pink, I think, just because pink will be bright enough. Good. All right, so taking a look at this, a vector, we got this one. A vector is an arrow showing magnitude and direction. That is absolutely correct, right? Vectors are arrows. Unbalanced forces. Do unbalanced forces cancel out or no? Tell me in the chat box. Do they cancel out or no? No, they don't cancel out. So you do end up with a net force. You do have a net force. So if you do have a net force, it should accelerate. And in this case, it's going to accelerate in the direction of the net force. All right, balanced forces, on the other hand, balanced forces we know do cancel out. All right, so these do cancel out. And if they do cancel out, net force equals 0. And anytime we don't have a net force, we don't have an acceleration. So the object will stay at rest. Smiley faces if that correction makes sense, everyone. I know unbalanced is a little bit of a difficult term to understand. Good. All right, this is number 3 in your lab. Give me a green check when you have it saved. You have 45 seconds. Go. All right, Alejandra, Alicia, Alicia S. Chris P, Danny, Estella, green checks, please. Jarrett, Jordan, Jorge, let me know that you have number 3. David, really quick, going back to number 2. So number 2 was this first scenario where up and down canceled out, but left and right ended up being negative 30 newtons, meaning that it moved left. So for number 2, it's negative 30 newtons going to the left. All right, let me know if that makes sense, David. Everyone else, are we good? David, are you good? Thumbs up. All right, David, I'm going to go ahead and move on. But again, if you need it back, I will move it back later on, okay? Awesome. All right, so here is the purpose of our lab. So the purpose of our lab is to look at how different forces influence an object's motion, specifically how opposing forces influence an object's motion. So remember, an object at rest is going to start moving in the same direction as whatever its net force is. So if it ends up with a net force from all these different weights working on it, it will end up moving in that direction. So for example, let's do a brainstorm. If you have a fridge with a friend, how are you going to combine forces to move this object more easily? Think about this. Let's say that this person is pushing to the right. What should this person do to make their lives easier? Let's say the person on the left is pushing to the right. What should the person on the other side be doing to make their lives easier? Good catching your mistake, Michelle. What do we think? Julian's typing, Kimberly's typing, Micaiah, thank you, Vanessa. Yeah, they should pull in which direction though, right? So we've got the guy on the left pushing to the right. And the guy on the right should also be pulling in the same direction to the right. Yeah, so we've got this guy pushing to the right. And this guy on the right, to make their lives easier, should also be pulling, but also to the right. Smiley faces if that makes sense. So it doesn't matter if they're pushing or pulling as long as both of them are going to the right. Both of them should go to the right. So to make their lives easier, they both move in the same direction. So both forces go in the same direction. Let me type that up. Both forces go in the same direction. Now, on the other hand, what happens if they work against each other? So let's imagine the guy on the right is pushing to the right and the guy on the left is pushing as well, but because he's pushing, it's actually going to the left. So what do you think is going to happen if they're both pushing against each other? Right, so we've got the guy on the left here pushing to the right and the guy on the right pushing to the left. So they're pushing in opposing directions. What's going to happen to the fridge? Okay, Asia, stay after class and I can help you out with that, okay? David's having a similar problem, so I can check out your computer and see what's happening. Yeah, so in this case, if they're working against each other, the net force is actually going to be 0, and they're going to stay at rest, unless one of them is stronger. So let's imagine the guy on the right is stronger. So if the guy on the right is stronger, then what happens? Tell me in the chat box. So if they're the same strength, let's think about this, same strength, same forces that are opposite, it's going to be 0 newtons, cancels out, stays at rest. But if one of them is stronger, so let's say the guy on the right is stronger, if they're opposite, then one of them's going to win. But is he going to win quite as much as if the other person was helping him? Is he going to win quite as much? No. So if they're still opposite, but one is stronger, then most of it cancels out. Most cancels out and it moves slowly. It accelerates slowly in whichever direction the net force is. Accelerates slowly. Smiley faces if that makes sense. So again, this idea of opposing forces, they cancel out some of the force, making it harder to do something, making it harder for an object to move. Awesome. All right, so this is going to be a virtual lab. I, again, recorded the entire lab for you so that you guys don't have to worry about opening up the virtual lab because I know, again, Adobe Flash has been giving us issues. I'm going to do the same thing for the old lab in case you haven't done the old lab yet. I just haven't gotten a chance to do that yet. I know. Why would they fight against each other, Landon, right? So again, I recorded the video for you, so you just need to get the data from the video. So I give you some examples, and then you have to get the rest of the answers on your own. So there are a couple answers I give you just so that you know how to do it, but the rest of them you need to do on your own while watching the video. One more time, give me a thumbs up, everyone, if that makes sense. So I've already done the entire lab for you. You just need to watch it and get your own data from it. Excellent. So you do not need to open up this virtual lab. All right, there's no way you'd be able to because I didn't give you the link for it anyways. Cool. All right, so you do need to have a Google account. If you don't have one, it takes 30 seconds to make. This is a drawing one, so I will show you in the video how to use Google Drawings, but you will be drawing your answers. It's not a graph this time. Okay, so it's just a drawing, which is pretty fun to play around with. So make sure you have a Google account. You can go to accounts.google.com/signup. Make sure you write down your username and password because we do use this the entire quarter. If you already have a Google account, great. Don't worry about this. Okay. The instructions do have every single step. Again, I do the entire lab for you. You just need to get your own data from it. Watch every step, pause it, complete it on your own. Make sure you listen to audio because most of what I tell you is audio. I explain to you how to do everything, okay? But I don't actually draw it on the board because that would be giving you the answers. So make sure you're listening as well. And then all of the instructions are over here, but again, that's all in the video for you. Hello students, these are the instructions for the 3D lab report. At this point, you've already answered questions 1, 2, and 3 in the live class session or the recording from the live class session. So at this point, we're going to move on to question number 4, which is where we're actually going to do the lab. Now I am going to do all of the steps of the lab for you. You just need to get the data and complete the assignment based on the scenarios that I show you. All right, so you can see here what you're going to do is you're going to click on the template link right here in question number 4. And then when you do that, you're going to confirm that you would like to make a copy. And now once you're here, you're going to go ahead and up here where it says your name here, please type your name. So for example, I'll put Mrs. Larkin, but you would put whatever your name is. So put your student name up there just to make it easier for me to grade, to make sure I don't grade the wrong student's lab. Now, what we're going to do is we're going to first fill out the masses that you see right here. Then we're going to go ahead and complete these scenarios. And I do have an example scenario right here for you that'll show you. And then again, I will be showing you all of the scenarios, but you will need to be drawing them on your own. I will not be drawing these ones for you. You'll need to do it based on the example that I showed you. Okay, so what we're going to do is I'm going to go ahead and open up the lab for you and show you what this looks like. And again, you don't need to do this. I'm opening it for you. I'm doing it for you, okay? All right, so let me go ahead. I'm going to actually move this over a little bit just to make it so I can see everything. All right, so I'm going to go ahead and here are all the masses that I was talking about, and I need to go ahead and I need to actually measure all of the masses. So I'm going to start off with silver. I'm going to give you a few examples, and then I'm going to show you what the rest of them look like, but you will need to measure your own data. So pause whenever we get to all the rest of them, and that way you can actually measure your own data for those. So for example, I'm going to go ahead and pick up the silver mass and hook it onto the scale right here. And when you zoom in, you can see that the line right here, this line that tells me how heavy it is below 20, before this middle line that's halfway between 20 and 25. And what's important to understand here is that as you go down further, the mass is actually getting heavier. So you can see 20 newtons and then 25 newtons. So the lower the line is, the heavier the mass actually is. And you can see that right here. I do have an example of that where 20 newtons and then this line must be 22.5 because it's halfway between 20 and 25. So since it's below 20 but above 22.5, I'm going to guess that this mass right here is going to be approximately 21. And so I'm going to fill in right here that the silver mass weighs 21 newtons. Please make sure you include N for newtons, otherwise you will lose points. So you do need to say 21 newtons. All right, so that is the weight of this mass. Now we're going to go ahead and move on to the black one. I'll show you an example of the black one. All right, so I'll hook that one on, zoom in so that you can see this. And this one you can see is just a tiny bit below this halfway line between 15 and 20. And again, this diagram shows you the halfway line between 15 and 20 is 17.5. So since it's just a tiny bit below, I'm going to say that this one is actually 18 newtons. Again, I need to round up because it's below the line, and the lower you go, the higher the weight actually is. So this one should actually be 18 because it's slightly lower, meaning it's slightly heavier. Okay, so that's silver and black. Let me go ahead and show you a couple of the small ones, and then you're going to do the rest of them on your own. I will show you them, but you need to be able to do them on your own. So let's go ahead and do the small red one, for example. The small red one you can see is at this line at the very, very top, and I showed you up here in your help diagram here that this line at the very top is actually 2.5 newtons. And last but not least, let me go ahead and show you one more small example. So let me show you the purple one. And the purple one, oops, yep, there we go. Zooming into that, you can see is now a little bit below that 2.5 line, and it's actually very, very little below, so I'm just going to add a tiny bit. And since I'm just adding a tiny bit, you can see I'm going to mark this as 3 newtons. Okay, so the weight of this due to gravity is 3 newtons. And again, the reason it's a higher number is because it was below the line. Anything below the line is actually a bigger number. All right, so I'm going to go ahead and show you the rest of these. I am not giving you the answers for these ones, but I am going to show them to you so that you know what they look like, and then you can fill it out on your own. So sorry, let me make this a little bit bigger again. Okay, so dropping on the orange one. All right, so you can see the orange one right here is at this line. So go ahead and pause the video and fill out how much the orange weight is, how much the weight of the orange mass is. All right, here's the next one. Again, you're going to pause the video once you have the measurement. So here we go. We can see this one is a little bit below the halfway line between 10 and 15. Right, so think about what's the halfway line between 10 and 15, and it's a little bit below, meaning it should be a little bit larger than this number. All right, so go ahead and fill out the answer for the yellow one. Pause the video, fill it out, and then continue. All right, let's go ahead and do the green one. So dropping on the green one. All right, looks like the green one is right here at this line. So go ahead, pause the video, and fill out how much the green one weighs. Again, make sure you're including the word newtons. Include the word newtons. All right, so now we need to do the brown one. So let's take a look at this one. I'm gonna drop that, grab this brown one right here. And the brown one you can see is at the halfway line between 5 and 10. So again, you have this helpful diagram that tells you how much the halfway line between 5 and 10 is. So fill out the brown one with the word newtons. Let's go ahead and do, what's our next one? The light blue one. So I'm going to take this, drop it down here, grab the light blue one. You see the light blue one ends up at this line up here. So pause the video, fill out how much the light blue one weighs. And lastly, let's go ahead and do the dark blue one. So here's the dark blue one, dropping that on. And the dark blue one looks like it is a little bit more below this line right here. So I would say that it's got to be heavier than the purple one, right? So the purple was 3 newtons, but it's got to be a little bit heavier. So think about what's slightly heavier than 3 newtons, and that'll be your dark blue one. Okay, so now that we have all of the weights of the masses, all right, I'm going to go ahead and drop that off. We're going to go ahead and do our scenarios here. So here's what I'm going to do. I'm going to go ahead and show you an example. So for now, I'm going to go ahead and just grab the 15 Newton block, all right, which is actually our orange one. And I'm also going to grab the 3 Newton block, which is the purple one. Okay, and I'm going to go ahead and show you an example. So I'm going to go ahead and go to the actual lab station. And you can see on the lab station, we have a block right here. And what we're going to do is we're going to be dropping off the blocks, dropping off the masses on different sides of the blocks, then letting go of the block and seeing which way the block actually goes. Because whichever way the block begins to move, we know based on our class that that must be the direction of the net force. Okay, so based on my example right here, let me zoom in just so you can see this. All right, so my example right here said that on my block, I have a 15 Newton mass going off the bottom, and I have a 3 Newton mass going off the right side. So I'm going to grab the 3 Newton purple one and drop that off on the right side. And for all of the rest of these, again, you will need to actually know the weights of the masses. I will not be giving you them. I'll just tell you which color it is. And based on what masses you put up here, what weights you put up here for the masses, that's how you'll know how many newtons you should put. Okay, so let me go ahead and show you what this actually looks like so you know how to draw these. Okay, So here we go. So what you're going to do for your, again, this is an example, so you don't need to do this, is the 15 Newton mass, again, is going downward. So I'm going to draw an arrow using the arrow tool, which is this long one, slender one with the point. So you click on that one and you draw your big arrow. Okay, draw your big arrow right here. And the reason it's a big arrow is because it's 15 newtons. I know the orange one is 15 newtons, so it's much heavier. And so the heavier it is, the longer your arrow should be. So this is going to be 15N for 15 newtons. To type, all you need to do is you need to click on this text box, this T box, draw a little box right here, and then type 15 newtons. Okay, again, this is my example, so you don't need to do this one, you just need to watch. Now to draw my smaller mass, which is the 3 Newton one, again, I'm going to click the arrow right here, this second slender arrow. I'm going to draw a little arrow because 3 newtons is much, much smaller. The purple mass is smaller. I'm going to grab a text box, the letter T, and draw a little text box and write 3 newtons, because again, I already know that my purple mass weighs 3 newtons. Now from here, I need to figure out the net force. So to figure out the net force, we're going to let go of this and see which direction this block now moves based on the net force from these weights, from these masses. So you can see that it actually moves slightly diagonally and off the bottom of the table. So I'm going to go ahead and draw that. Again, click on the arrow tool, the drawing tool, not the pointer. So the drawing arrow tool. And you can see here that it went downwards and slightly diagonal. So because it moves downwards and slightly diagonal, I know that this is the net force, the result of the two masses combining, the two different weights combining to create a net force on that block. So I'm going to type next to this line that this is the net force. Make sure that you always label very closely which one's your net force, kind of move it closer to it, and make sure that your weights are labeled very closely. Otherwise, I might not know which one is which, and then you will get marked off. So make sure that it's very obvious which ones are your masses, which ones are your weights, and which ones are your net forces. Okay? All right, so we saw the force of the 3 Newton weight, the force of the 15 Newton weight combining to create a net force that was down and to the right, which should make sense. It's closer to the 15 Newton, but slightly to the side because the 3 Newton is adding another force. Okay, so now what we're going to go ahead and do is I'm going to go ahead and actually do these examples for you, these scenarios for you. And you're going to go ahead and answer the scenarios. Again, you're going to draw the you're going to draw the weight of the mass that we put on the blocks, and then I'm going to let go, and then you're also going to draw the net force. Again, make sure that you label both the weights as well as the net forces very closely so I know which one is which. Okay, so I'm going to go back here. I'm going to actually go ahead and grab some of these different weights here. Okay, so let me go ahead. I'm going to grab the yellow one. Again, you should already know what these are because you've already paused the video and answered what all of these are. And I'm not going to be able to fit all of these on. So I'm just going to do as many as I can. All right. Okay, so for the first scenario, I'm going to go ahead and I am going to grab the green mass, the green weight here, and I'm going to go ahead and drop that off the top. So you should draw an arrow. Sorry, let me actually drop it off to the left. Sorry. So you're going to draw an arrow to the left with your green weight. And again, you should already know the weight of the green mass, and you should label it going to the left using your arrow tool and your text box tool. And then I'm going to let go, and you're going to see which way does the net force go. So I'm going to let go. And the net force is going to the left towards that weight. So again, your arrow will actually go in the same direction as that weight, which should make sense because there's only one weight to pull on the block. So your net force is also going to be drawn that way with another arrow, and you're going to go ahead and again label that as net force. So you should have one arrow going to the left with the weight of your green mass, as well as one arrow going to the left with the words net force. Okay, so now we're going to go ahead and do scenario number 2. Make sure you have paused the video and done this one. So now we're going to do our next scenario with 2 masses. So now I'm going to have my green one to the left again. So again, you're going to draw an arrow to the left with labeling it with the weight of the green mass. And then we're going to go ahead and grab another one, and I'm going to drop it off the top. So I'm going to grab the, let's see here, this light blue one. and the light blue one I'm going to drop off of the top. Okay, so this way you should draw another arrow going upwards, and keep in mind that the light blue one is going to be lighter, so your green arrow should be longer and your light blue arrow should actually be shorter because the light blue arrow is a smaller weight. And then you're going to go ahead and label that with the weight of the light blue weight as you did up here. So once those are labeled, make sure you pause the video, then I'm going to go ahead and show you the net force, and you're going to draw the net force. So here we go, letting go. And you can see that the net force does not go completely in between them. It does go diagonally, but the net force actually goes closer to the green weight. So you should make sure you draw your diagonal closer to the green weight and label that as your net force. All right, so for our next one, we're going to add a third mass. So again, I'm going to set this up the same. So green on the left, light blue on the top, and then I'm going to go ahead and grab the yellow and drop that one off the right. So this time we should have a medium green arrow going to the left labeled with its weight. We should have a small arrow going up labeled with the weight of the light blue mass. And then we should have a big arrow going to the right with the weight of the yellow mass. All right, so make sure you do that with your arrows and text tools, and then pause the video, and when you're ready, continue playing, and I'll show you the net force. All right, so we can see this time the net force actually went pretty much completely diagonally between the blue and the yellow. So we're going to go ahead and make sure we draw a diagonal going between the blue, the light blue, and the the light blue and the yellow masses. We're going to draw that diagonal going up and to the right, and make sure you label it as your net force to show that that's your net force. Lastly, the last scenario asks us to balance 3 masses so that the block does not move. All right, so what I'm going to do is I'm going to go ahead and drop a green mass off the left, and this one's going to be, actually, let me reset that. So I'm going to drop the yellow one off to the left. All right, so you should draw a big arrow to the left with it labeled with your yellow weight. And then on the right, I'm going to go ahead and drop 2 more weights. So I'm going to go ahead and drop the green one, which is kind of a medium weight. So this will be a medium arrow labeled with the weight of the green mass on the right, pointing to the right. And then I'm also going to drop off the purple one on the right, and that's going to be a very small arrow. The purple mass is much smaller, so that's a small arrow to the right labeled with our 3 newtons. We should already know that one weighs 3 newtons. All right, and I'm going to go ahead, pause the video, make sure you have one big arrow to the left labeled, a medium arrow and a small arrow to the right and labeled, and then play the video and I will show you the net force. All right, so in this case, the block does not move, so your net force should equal 0. So you need to actually type that in, that your net force equals 0 newtons, meaning that the masses are completely balanced, there is no net force, and therefore the block does not move. So again, this time you don't need to draw an arrow for net force, you just need to type out that net force equals 0. Okay, so once you have all of that done, you filled out all of your masses, you have the arrows for all of your weights, and those are labeled, as well as the arrows for all of your net forces, unless your net force equals 0, in which it's typed. Then you can go ahead and grab the shareable link, and that's what you're going to put into question number 4. So you're going to click share, click get shareable link, click copy link, and then paste it in here. Do not give me the URL at the top. If you give me the URL at the top, you automatically get a 0 because I cannot see your lab. This is your personal URL and I do not have access to it. So instead, you're going to go ahead and click share, click get shareable link right here, click copy link when that pops up. And then over here, again, you're going to right click and click paste. If you have a PC, you can also press Control and the button, the letter V at the same time. Or if you have a Mac, you can press Command and V at the same time, and that will paste this into here. And that's all you need to do, and then you can go ahead and submit. Make sure you confirm again that you want to submit. It always asks twice, and then you are all set. Thank you, everyone. Our objective for today was to be able to understand the magnitude and direction of net force using vectors and explain how different forces can influence an object's motion. How do you feel about this objective so far? Very confused? Still need help? Pretty good? Awesome. Think about all the math problems we did together. Think about the fridge exercise. How are you feeling? Go ahead, point on the board for me. How are we feeling? Awesome. Looking pretty good. And remind yourselves, what's one thing that you learned about today or reviewed today? Think about net force, think about vectors, think about motion, acceleration. Awesome. Looks like we're feeling good. I'm going to go ahead, pause that. So you're going to continue the 3D lab report. Again, the link to the instructions for number 4 is in the chat box. It's, I think, 82 points, so it's a huge amount of the lab. So make sure you do number 4. Number 1 through 3 is not a big part of your grade. It's due at 4 p.m., but you don't have to turn it in by 4 p.m. Remember, it usually takes me a few days to grade them. So it's more important for you to do it right. So just make sure that when you turn it in, you've done it correctly, because again, it's a huge part of your grade. So once the recording stops, I will give you the end of class word for the attendance check. So let me go ahead and stop the recording here.